engineering statistics and linear algebra. Today we do discuss a dimension of a vector space. Dimensions of what is the dimensions of a column space, what is the dimensions of a null space, and so on. Let us we see the definition of dimensions of a vector space, followed by some of the examples. A definition for dimensions of a vector space: if V is spanned, means a linear combinations. If V is spanned by a finite set, then V is said to be a finite dimensional, and the dimensions of V written as dimensions of V, this is the notation, and it is defined as it is the number of vectors in the basis for V. This is the definition. A dimensions of a vector space, it is the number of vectors in a basis for a V. That is called as a dimensions of vector space. The dimensions of the zero vector space is defined to be 0. Means a vector space having zero vectors in it means zero vectors, no vectors available in the vector space. Then what is the dimensions of that vector space? That is 0. Because the definition of a dimension of a vector space is number of vectors in a basis for the vector V. So that vector space is having the 0 vectors, then the dimensions of that vector space is 0. If V is not spanned by a finite set, then V is said to be infinite dimensions. Let us solve some of the examples here. Find the basis and the dimensions of the subspace. The vector given W as A plus B plus 2C and so on, and they have defined A, B, C and D are real numbers. For this, let us calculate a basis and the dimensions of the subspace. So let us rewrite the given equation. That let us write the given matrix in another format in terms of free variables. Let us write given matrix in terms of free variables. So the LHS matrix can also be written as, so A into 1, 2, 1 and 3 with this matrix, and B into 1, 2, C and 3. Sorry, 1, 2, 1, 0. Okay, what about C? It is 2, 4, 1, 3. That is written here. Write D components. Here 0 into D. That is written. Next is 1, 1, 1. Okay, alright. The given equation can also be written in this form in terms of free variables. Alright. Now, W is what here? The linear combinations of V1, V2, V3 and V4. We have observed it has 4 vectors in it. This vector W can also be written as linear combinations of vector V1, vector V2, vector V3 and vector V4. That is said here. Alright. So where V1 is this first matrix, second, third and fourth. Now you can observe V3 is dependent on V1 and V2. In other words, V3 can be expressed in terms of V1 and V2. That is written here because V1 plus V2 is V3. V1 plus 1 is 2, 2 plus 2 is 4, 0 plus 1 is 1, 3 plus 0 is 3. Out of these 4 matrices, what are the bases for this W? So V3 is redundant here, so that it can be expressed in terms of V1 and V2. Then the basis for this W is only V1, V2 and V4, because v3 is dependent vector here. It depends on v1 and v2. It can be expressed in terms of v1 and v2, but v1, v3, v2 and v4 cannot be expressed in any other forms of v1, v2, v3 and v4. So that out of these four vectors, v3 is redundant. Then what is the basis for these vectors? The basis for these vectors are only v1, v2 and v4. Then what could be the answer for dimensions of this vector? Dimensions of vectors. So it is only 3. It is only 3. So we have solved the one problem here. Next, let us solve the one more problem. Suppose A is this matrix, then find dimensions of a column space A and dimensions of the null space A. The first thing is, let us calculate column space of a given matrix, null space of a given matrix. Later, observe the number of vectors in that. That is the answer for the given question. First, calculate the dimensions of a given matrix. This is the given matrix. Convert it into reduced row echelon matrix. For that, minus 2 times the r1 minus 2 times the r1 plus r2, that gives r2 here. Do this operation. What happens here? Multiply minus 2 to the first row and add with it the second row. The minus 2 and plus 2, it is 0. Minus 2 into 2, 4. Minus 4 plus 4, it is 0. Minus 6 plus 1, it is plus. Minus 6 plus 7, it is plus 1. Then minus 8 plus 8, it is 0. Now it should be in row reduced form, row reduced echelon form, so that still it can be converted into what I can say, r1 is equals to r1 minus r2, so that this 3 becomes not 3 times 3 times r1 equals to r1 minus 3 times r2. What happens here? This becomes 0. This also becomes. Now it is in row reduced echelon form. Now it is in a row reduced echelon form. Then what is column of a given matrix? Let us know the pivots of this matrix. What are pivots? These two are pivot positions because the leading element of that row is 1 and corresponding row having all 0 terms except that leading one. Similarly, this is a pivot position because in this particular row, except that leading element, other elements are 0 here, so that these two are pivot positions. Then what is column of the given matrix? Only column number 1 and column number 3, that is written here. Then what is dimensions of this matrix? Dimensions of column of A equals to number of vectors. Number of vectors in this column matrix is only 2, so that the answer for the question is, it is 2. Now let us find out the null space of a matrix. So for that, augmented matrix should be considered. This is the echelon form. Zeros are appended to the right so that it gives augmented matrix. Convert that matrix back into equivalent system. So 1 into x1, 2 into x2, 0 into x3, 4 into x4 is equals to 0. From the second row, 0 into x1, 0 into x2, 1 into x3, 0 into x4, that is equals to 0. That is written here. Solve for each variables in terms of the free variables. So this can also be written as 2 terms are missing here from this equation. They are x3 and x4 that can be written here. So sorry, x3 is there, but x2 and x4 are missing. That can also be written as x2 is equals to x2 because it is 0 only, x4 is equals to x4, that is 0 only. And write x1 in terms of other variables, similarly x2, x3 and x4. Then write in terms of vectors. All these things in the left hand side can be written in this vector form, and these vectors can be written in terms of minus 2 into x2, x2, 0, x2. This equation can also be written as 0 into x1, 0 into x2, 0 into x3. It is also can be written as 0 into x1, 0 into x2, 0 into x3, 0 into x4. And this is 0 into x1, 0 into, already x2 is there, then 0 into x3 plus 0 into x4. Write all four variables here, then write it in a vector form. Write it in vector form, so that first term is minus x2, second term is x2, then the third term is 0 and 0, and so on. We do get this equation. Next thing is a factor out. Take a common from each term. From this column, the x2 is common, taken outside, x4 is common, taken outside. Then basis for the null space is these two vectors. This is the vector 1, this is the vector 2. This is the basis for the null space. Then what could be the answer for dimensions of a given vector? The dimensions of the null space. The dimensions of the null space equals to number of vectors in a null space. There are two vectors are available in a null space. Then answer for the dimensions of the null space is 2. Alright. So let us we solve some more examples here. Already this problem is solved. We have calculated null space and the column space for this given vector. Uh, then the column space for this vector is 1. Then what could be the dimensions of this vector? The dimensions of the column space, it is 1 because it is having only one vector in a column space. Then what could be the null space for this given vector? That is calculated here. We have considered the augmented matrix, free variables represented in vectors. Finally, this is the answer for null space of a given vector. Then what could be the answer for dimensions of a null space? That is equals to 1 because it is having only one vector. Then consider this problem. First calculate column space and null space. After that, find out the dimensions of a null space and dimensions of a column space. We have calculated a column space of the given matrix, converted into reduced to echelon form. Then positions of a fields are noted. Then those two columns are nothing but a column space. That is done here. So what could be the answer for the dimensions of this vector? It is a 2 because we do find only two vectors in a column space here. Then let us calculate the null space of a given vector. Consider the augmented matrix, then written in terms of free variables, and finally represented in terms of vectors. Then finally we do have only one vector here in a null space. Then the dimensions of the null space for the given vector is only 1 here. Then this problem is also solved. What could be the answer for a column space of this? Column space is nothing but the positions of the pivots. Columns that where the positions of the pivots are found, that will be the answer for the column space. But already this matrix is in a reduced row form, but we don't find any pivots here. we don't find any pivot, then what could be the answer for column space? It is zero vector. The answer is the zero vector space. We don't find any vectors in a column space, then what could be the answer for dimensions of a vector A? That is equals to 0. The meaning of this is no vectors in a column space. Similarly, for the same matrix, let us calculate the null space. Calculated by considering the augmented matrix represented in vector form. Factors are taken common. Finally, we do find a null space for the given matrix is this. Then dimensions for this vector is 3 because we do find a 3 vectors here. For this, we have calculated column space. Then the dimensions for this vector is a 2. Null space, we have calculated a null space for the given vector is this. Then the answer for dimensions of a null space is 1. Alright. As a conclusion, I can say the dimensions of a column matrix or dimensions of a column space that can be written as number of pivots in the columns of A. This statement is one conclusion for it is taken because of this discussion. Then what is the dimensions of a null space? That is equals to number of free variables in A. Okay, these 2 points should be considered. So that gives dimensions of column space A and dimensions of a null space A. In next video we will discuss rank of a matrix. Let us we see in the next video. So please like, share, comment on the video, and don't forget to subscribe this channel. Thank you.